everyone to this month's Energy, Environment and Sustainability Group lecture by Daniel Kenning on behaviour, change and sustainability. I'm Rupert Blackstone, the chair of ESG, and I'm pleased to introduce Daniel, who is a fellow of IMechE, a former chair of ESG between 2007 and 2014. He is co-founder of the Transition Engineering Movement in 2009 and GATE in 2013. And he is a specialist in engineering for sustainability and thinking differently. And please, as Daniel gives his presentation, think of when you think of questions, please click on the Ask a Question and plenty of questions as we go along. There is a bit of lagging in questions, so it's best to get them in early. And I'll pick up with you after the talk, and I'll let Daniel continue, and I'm sure he'll make us all think differently. Thank you very much, Daniel, and we'll look forward to your presentation.
Thank you, Rupert. I'm just going to switch on my slides then. Okay, so I'm hoping today to talk about some ways in which you can all, as professionals, make a much bigger difference in the move towards sustainability. That's what I'm aiming to do today. So and this is not just for engineers, this is for all professionals, recognizing that we don't operate in silos. We should all be working together. So Rupert's already said, I'm still a member of the IMechE Energy, Environment and Sustainability Group. I co-founded the Global Association for Transition Engineering. And in fact, some of the tools that we talk about in transition engineering are what I've used in this webinar today to think about this business of behaviour change. I'm a fellow of IMechE, chartered engineer and chartered environmentalist, and we'll talk about those two a bit later on. And they are a chartered engineer, chartered environmentalist, and also a member of the Global Association for Transition Engineering. So what do we mean by the words that we're using? Okay, and these are definitions from the OED. I just want to say why did I propose giving this webinar today? And it's because I realized that the terms behavior change and of course the term sustainability are used widely and often used in senses that I thought were maybe not completely as constructive and effective as they could be. So I thought, well, what do we really mean by this? And I always go back to the OED to understand what a word is meant in common usage. I'm a great believer in using the words we've got rather than inventing new jargon. Sometimes I think that creating new jargon is just laziness because we don't understand the words we've got. So here's the definitions from the OED, Oxford English Dictionary. Behaviour means several things, including a course of action. And changing behavior can be a noun or a verb. And we're talking about it in the sense of altering, modifying, or transforming our course of action. So that's what we mean by behavior change. And by sustainability, this is an interesting one because the recorded definition of sustainability, you can see it here. Firstly, it means the quality of being sustainable by argument, the capacity to be upheld. So that means the capacity to continue. But sense two is only about environmental sustainability. And I think this is a weakness in the current definition, which will hopefully be amended. And my definition that I've been using since 2001 is that sustainability means the capacity to continue. So, and sustainable, the adjective, means having the capacity to continue. So I'm going to be talking about how we can change our course of action to help achieve the capacity to continue. Okay, now as a good engineer, I'll describe the problem now. What is the problem that we're looking at? Well, one of the fact is the society depends absolutely on complex engineered systems. So that's not just social systems, but systems like buildings, food, water, healthcare, transport. These are all engineered systems. Society depends on them. And nearly none of these systems actually have the capacity to continue within foreseeable constraints. There you are. So none of our systems actually have the capacity to continue, and that's a whole other discussion. But this is my understanding. Also, nearly no change has been achieved in 50 years since we knew what the problem was. And by this, I mean that all of the indicators of unsustainability, all of the indicators of the problems like climate change, biodiversity loss, social inequality, all of those indicators are still going in the wrong direction, even though we've known about the problems for such a long time. So basically, we need to change direction. And it's this change of direction which is at the core of transition engineering and at the core of what I'm thinking about when we're talking about behavior change and sustainability. We're talking about changing direction. And to look at a nice picture, here we are for all of those motorcyclists online today. Here we have a very happy person on a motorbike approaching a corner, and we can use this as a way of describing our current unsustainability problem. We've been going in one direction, like this motorcyclist, for some time, very successfully. We have the technology that allows us to go in that direction. But there are lots of signs all around us that say we have to change direction. So our current behavior is that we are cycling, or we're motorcycling, or we're traveling along in our society in a particular direction, a direction that has been quite successful for quite a long time. But now there are some signs that tell us that if we carry on in that direction, the outcome will not be very favorable. That doesn't mean that there's anything wrong with our motorbike. It doesn't mean that we're riding it wrongly, but it means we have to change direction. And technically, the person riding the motorbike is free to ignore all the signs and to carry riding straight on and crash. They're technically allowed to do that. And in the same way, in industry and in business, we are legally allowed to make very bad decisions about not changing direction. But actually what we need to do is change direction, and the outcome will be that we've got a changed behavior, but we haven't crashed. We're still very happily riding our motorbike and enjoying all of the things that you can enjoy as you ride along, but we've changed direction. We've got a new behavior going in a different direction, and that's what the challenge is that we're trying to achieve in transition engineering and also in our behavior change discussions today. We're trying to change behavior, change direction. Okay. So another question that occurred to me is, why, when you hear about behavior change, do we hear about it in terms of behavior change for consumers? And the key thing that I want to do today is talk about behavior change as professionals rather than consumers. But I did look up why this consumer word is used instead of customers, and I discovered that from the end of the 19th century, a situation was arising that the Industrial Revolution had led to such successful production systems that companies were in the situation that their sales were stagnating, and they were able to provide everything that was needed for people without increasing production. So they could have chosen a stable pathway and only produce what was needed. And I understand that around the turn of the 19th, 20th century, such an economic solution was proposed, but instead attempts were made to boost sales through the propulsive power of envy. And this is when the advertising industry started selling things more. In the 19th century, there was a definite move of consumption of goods and services beyond subsistence, starting with food, but also with goods. And this was when we saw the emergence of the retail sector as a machinery of enticement to get people to consume more and more. In the 20th century, we've seen the ever extendable consumer desire characterized as progress. So progress is described as where we want to go by selling and buying more and more stuff. And this is the image that I have in my mind, that we've been sold the idea that the best thing we can possibly want is more, newer, faster, bigger, everything. Now, at the beginning of the 21st century, we're starting to see discussions about behavior change. And I believe that if this is framed in the context of consumer behavior, and the discussion is framed only as behavior change in the consumers, which is choices about what they buy, then I believe this is an attempt to shift responsibility away from industry and onto consumers or customers. And as such, it is an attempt to continue business as usual, consumerism, and selling more stuff, rather than addressing the need to change direction and then adapt our systems to suit that new direction. So that would include manufacturing systems, retail systems, business systems. Okay, so this is what I see as the history of why we've ended up with a focus on consumer behavior. Now, this is not to completely deride changes in consumer behavior. I'm just going to show you an example about how changing consumer behavior can in fact work. And this is an example from some time ago, about 30 years ago actually. And this is the United Nations Environment Programme on eco driving. And now I used to work at Ford, and in 2004 a workshop was conducted with Ford of Europe in Germany, with 300 people. They were all given a 1-hour training course on how to drive in different ways. So this is all about behavior change when you're driving a car. And after 1-hour training, they all achieved an average petrol saving of 25%. But during the urban driving cycle, so they were tested over an urban and a motorway and an average cycle. The savings in the urban cycle, which is where most car driving happens, was 41%. So those are the savings. So this shows us that behavior change can achieve an enormous difference. So 41% fuel saving just by the way you change, by the way you drive a car. And if you compare that to another program that was going on at the same time when I was working at Ford, some colleagues of mine were involved in a new engine program. They spent 2 to 5 years redesigning an engine. It was a very ordinary 4-cylinder petrol engine for one of the Ford cars. And between 2 to 5 years, they spent between 5 and 10 million pounds. It obviously depends where you start counting from. And they achieved between 1 and 2%. I can't go and ask Adam. They achieved between 1 and 2% fuel savings. So you can see that although those aren't directly comparable examples, the impact of behavior change can be very high and very affordable. Okay, but let's look at where consumer behavior sits in the conventional business model. Now, this diagram here, you've probably seen it. This is the typical diagram of a linear model for production of products. This is, we'll get to the circular model presently, but in a conventional linear model, where resources are taken by industry and sold as products into markets. And you'll see here, I've labeled this as consumers, which is the term that I think is out of date. And then products become waste at the end of life. Now, where does consumer behavior sit here? And it sits there. So consumers are our markets for our products, and the consumer can make a difference to the whole system by deciding whether to buy one thing or another thing at this point. So the point where products go from industry into the markets. Okay, so consumers are to some extent free to choose which products and services that they buy, and they can choose to buy products and services which are more effective at reducing unsustainability problems. But we have to understand that there are many factors that militate against those decisions, like the advertising I've mentioned, and whether or not products or services are available. So this is not really a very big lever that we can pull to make change happen, which is why I've tried to put together this webinar. So I've looked at why we should focus on consumers. I want to expand this to what our role is. And I'm assuming that the people who are on this line might be, there might be a lot of people who are engineers because it's an IMechE event, but I have tried to include other professionals as well. And so I hope there are some other professionals online. And certainly this discussion is aimed at other professionals as well as engineers. So that would be ecologists, social scientists, natural scientists, creative people, people in community roles, anything like that. So what is our role as professionals? Is it that? Certainly refusing to look at the problem or accepting the status quo is a behavior, but also thinking about it and effectively putting your head over the parapet and persisting and trying to resolve the thinking is another behavior. So this is what we're talking about today. Okay, now all of you as professionals, if you are a member of any professional body like IMechE, for example, you will already be subject to codes of professional conduct, and these are really sets of rules about how we behave already. And I've just extracted a couple of statements from the IMechE code of conduct. It says that all members of IMechE are required to maintain their knowledge and skills. So one of the things we do is we study and we learn and we listen to webinars and we contribute our own learning as well. So that's good. It says we have to act with integrity and respect for others. We have to promote sustainability. So that's actually part of how IMechE members should already be behaving. Within that, it says that we should recognize the importance of socio-economic and environmental factors. So we should already be thinking outside of the technology box and looking at other factors. Obviously, we should be complying with our obligations. And at the bottom here, we have to balance the needs of the present with the needs of the future. And this is beginning to incorporate the thinking around sustainability, that it's about the needs of future generations and not compromising those future generations to meet their own needs. So these are things we should already be doing. We should already also be exercising engineering leadership. So interpret that how you will, but these are some behaviors that as IMechE members we should already be practicing. Another code of conduct which would apply to all the people who are chartered engineers is the Code of Professional Conduct of the Engineering Council. And I'm quite pleased to say that the Energy, Environment and Sustainability Group of IMechE were instrumental in creating this guidance way back. I can't even remember when it was, a long time ago now. And this is still in place. This applies to everyone who's a CEng person, chartered engineer. And it says that you have to, this is an obligation, by the way, you have to contribute to building a sustainable society, present and future. This recognizes the definition of the practice of engineering, which the Engineering Council use, which is that engineering is the application of scientific learning to benefit society. And notice it says present and future. Again, it says you have to apply professional responsible judgment and take a leadership role. So you're supposed to lead, not follow. This is an important point when you hear discussions about engineering following government policy. Actually, professionally, we are supposed to be leading government policy, not following, especially given that so much unsustainability problems are the result of the complex engineered systems on which we depend. Okay, we are required to do more than just comply with legislation. We are supposed to be prepared to challenge the status quo. So as a professional engineer, we definitely should not be putting our heads in the sand and simply doing our job to get our salary. It says we should use resources efficiently and effectively. This one is more of a technical requirement of how we would behave in our professional work than a behavioral requirement. Seek multiple views to solve sustainability challenges. So this is the business of not just working in a silo, but reaching out to other professions, making sure that our engineering thinking is consistent with economic thinking, ecological thinking, sociological thinking, and so on. Okay. And finally, manage risk to minimize adverse impact and maximize benefit to people and the environment. Okay, so those are some points from the Engineering Council Code of Conduct, and there are many others. Every single institution will have its own, and some of them are a bit more mealy-mouthed. Some of them are a bit out of date. It depends on the age of the institution and when their code of conduct was amended, but you should all already be aware of these as well. Okay, now we looked at the conventional linear economy, and nowadays we hear a lot about the circular economy. So this is a typical diagram of the circular economy. I'm also pleased to say that the Energy, Environment and Sustainability Group was instrumental in advising the Ellen MacArthur Foundation on what a circular economy is before she was able to set up her circular economy project way back in 2011, I think. So we are at the place where that originated. So this is a model of the circular economy, and this is obviously where the idea is that materials go round and round in a circle instead of going from raw material to waste. And let's just think, where does, oh, you'll see here I've put customers here rather than consumers, and I call them as well service users, because a lot of the time we would be looking at providing services rather than products. Now, where does consumer or customer behavior sit here? It still sits there. So it's still about the decisions that consumers or customers make about what they buy. But my point that I want to explore here is that actually customer decisions or buying decisions are only part of the system. And also there's an argument that this is a theme that comes up often in transition engineering, is that you can't solve a problem with the same way of thinking that caused the problem in the first place. And if the problem is linked to how you think about buying stuff, then making decisions about buying different stuff isn't going to lead to a solution to the problems caused by buying too much stuff in the first place. So this is where customers can have an impact. How about professionals? How about us? How about engineers, economists, sociologists? Where can we have an impact? Well, to start with, over here, we can make decisions that reduce the resources that are needed to make the products. Then we can make decisions that reduce the waste during manufacturing. Then we can make decisions that reduce the degradation of materials during the processes. And I don't think nearly enough work has been done on that area of endeavour. We can make decisions about products that affect the customers, like extend the useful life of a product, increase the value in use. That means we can design products so that during their useful life, they become more valuable rather than less valuable. And we can think of some examples of those. They're few and far between, but the fountain pen on my desk is a very good example of that. And finally, we can make decisions that reduce impacts of products in use. Then for those materials that become wastes and don't go around the circle, we can make decisions that retain the value of the materials during their disassembly. And finally, there are many opportunities to make decisions to retain the value of materials during recycling. So my point there is that there are many more points during the whole system process where professional behavior can make more of a difference than just the customer behavior when they're deciding which things to buy. Okay, so I'm just going to show now, go quickly through a few examples of specific behavior changes, but there are many more. So the first one is what I call changing from the behavior called business as usual plus incremental change to transition. Okay, so here we often see that proposals of business as usual with an incremental reduction in harm. So this is, for example, a vehicle which has got a slightly more efficient engine or a catalytic converter on it. We still see gradual degeneration of the whole system. This kind of approach just delays failure and it's not sustainable. What we're looking for is a change in the developmental trajectory. So instead of business as usual plus a small change, we're looking for a whole change of direction. And we're looking for regenerative system design, and this can actually avoid failure and can be sustainable. So it's a huge difference. And this is the basis of the whole of the different thinking that underpins transition engineering. So if you can change from behaving in terms of business as usual plus incremental change to transition, then that will be a very good thing. Okay. Here's an example. This is the classic diagram of transition engineering. Step 1 to 2 is our current trajectory. Step 3 is incremental changes, which can all lead to failure anyway. Step 4 is transition to sustainability. And this green hatched area is the safe operating space where we hope we can operate in future. Another behavior is from more to enough with less. More to more, what more with more is how I describe the behavior that has been possible since the Industrial Revolution. All generations of engineers have been able to provide more for what people want, and increasing sales of what people want. but assuming that they've always had access to more energy and more materials than the previous generation. So in this model, we're protecting business as usual, and we have to assume that supplies are infinite, which we know is not correct. But at the moment, because we're going through a historical change, we now know that we have to make enough for people with less resources. We know there are resource constraints. So from now on, all engineers have to understand this. We have to understand what people need rather than necessarily what they want. We maybe have to assume that sales will be stable rather than perpetually increasing. And we have to adopt the challenge of adaptation, and we must assume that supplies are constrained and understand and work within that. So this is a behavior change from doing more and more and more and more and assuming that that is progress and that is better, to doing enough with less and understanding that that's a different definition of what is better and what is desirable and sustainable. Another behavior that we see a lot is selling technology, and we might think, well, that's what engineers are supposed to do. But actually, what engineers are supposed to do is create solutions. The selling of technology behavior is what you see as a technology push. We see lots of examples of substitution of one technology with another. For example, petrol cars are bad, so let's invent electric vehicles. Electric vehicles are amazing. The technology is brilliant and they work, but substituting 20 million electric vehicles for 20 million petroleum-powered vehicles isn't actually a solution. It's just a technology sale. This typically doesn't involve any system change. So substituting hydrogen for petrol and diesel without changing the whole system of transport is an example of this. Typically, technologies are called solutions. When I talk about technology, I mean hardware, like a motor or an engine, whereas a solution is a system changed so that something works. The most important thing under this behavior is what, as in terms of the hardware, so vehicle level solutions, engines and so on. But basically this is all about selling technology, and I would just like to warn you, if you hear a solution proposed that is expressed in terms of let's look for a solution which is this technology, then be warned that that's what's happening. When I talk about creation of solutions, I mean that technology follows the change. So you start off by understanding what change is needed, and then you design your technology to suit. You don't substitute one for another. You look at the system first. You look at your system change to meet needs rather than wants, and then you sell technology to support that solution. And the important thing here is how you make the change rather than what you change. So we talk about transition engineering as being the how to make the change now that we know the change is needed. And this is important as well because a lot of funding sources focus on hardware and the what and not the how, and it can be difficult to make progress in this field. So it's a challenge. Okay, so that's a behavior change from selling technology to creating solutions. Another one is a habit to get into is about finding good answers to good questions rather than good answers to bad questions. And a bad question might be, how can we do what we want to do with less harm by society to the environment? How can we profit short term and hide inconvenient changes? We might challenge that and try to answer the question, how can we do what we need to do without the environment harming society? That means, how do we work within the constraints from outside? And how can we prosper given foreseeable external changes? So we must recognize the constraints and recognize that we can prosper and we can change the system, but we have to make sure that we're answering the right questions. Another behavior change is accepting assumptions or challenging unstated assumptions. And I would like to encourage everybody to get into the habit of looking out for assumptions that are not stated and then challenging them. So we might accept that this way is the best way because we've always done it this way. We might accept that the client knows what to ask for and that they know what they need. We might flatter them by assuming that. We might assume also that the future operating environment will resemble the current operating environment. But actually, if we challenge those assumptions, and we always look for unstated assumptions, and always ask whether assumptions are valid, and especially about energy and material resource availability, then we can start having some far more constructive conversations with our clients or our employers or our community groups and start creating some really good solutions. Then we can change our behavior from pursuit of compliance to the pursuit of continuity. At the moment, I've heard clients saying that they want as little sustainability as possible. I think what they mean is as little change as possible whilst complying with legislation. But unfortunately, this does not guarantee long-term continuity. And again, we have to assume that they know what they want and they need. This also requires an assumption that if something is legal, it's sustainable. If you go back to the definition of of sustainability as the capacity to continue, you can see that there's a difference. So just complying with the law will not guarantee business success. And I suggest we need to pursue continuity instead, which is as much change as is needed to give confidence of continuity, rather than as little change as possible. Also, here's a key one for professionals. If you assume that you are the only person that your client has ever spoken to who might tell them what they need, then that puts a different perspective on the advice that you might give them. So assume that you are the only person they've ever spoken to who knows anything about sustainability. And just a little diagram here, you can see that along the bottom of this diagram, we've got an increasing scope of vision from compliance to risk to continuity. And up the top here, we've got increasing benefits. And you can see that if you only ever help your client to comply with the legislation, the only thing they can achieve is no penalties or no prison. But if you aim for continuity, then they can expect to achieve no end to their business, so they can prosper long term. Okay. The next one is possibly an obvious one: thinking in silos to what I call peer professional dialogue. We know it's generally a bad thing to only look inside your own profession and look at sector specific solutions. We know that. What I'm trying to encourage here is an actual how to get out of silos. And what I try to look for is building consensus across all professions, so that if you discuss a whole solution between different professions, then you should have a solution that makes sense across all professions. And then we can present consistent solutions to clients or to policymakers. Finally, we're getting to the stage where we can either assume that because I'm already I've already got my degree, I'm already qualified, I only need to use what I've already learned. And in some sectors, particularly quite mature sectors, we see quite minimum levels of professional development after people's main education. I call this sitting on your laurels and thinking, I have arrived, I'm an expert. What we need to look to is learning what we need. And this is more common in sectors which are younger. So like computing, mobile phone sector. In these sectors, there is far more agility and learning about what they need. And so I would just like to encourage you to learn, read, study, engage in transition engineering, of course, in the circular economy, in eco-design, in ideas about the limits to growth. Don't assume that you know everything already. And definitely this, as professionals, this involves working towards being a chartered engineer if you're an engineer. If you're not an engineer, working towards the status of being a chartered environmentalist, and continually improving yourself so that you can be more and more effective in what you are doing, and considering that you are always on your way rather than you've achieved where you're going to. And just as a few suggestions here of good reading, notice that these are just a few books I think are very worth reading. The first one, of course, you see is a book about economics. So I'm not suggesting you only find out about engineering. The Limits to Growth was recently revised, so that's a very good resource. Ray Anderson's book is an excellent book, wide-ranging book about how he addressed sustainability in his business. David Mackay's book about sustainability without the hot air is always worth having on your bookshelf. And the recent book by my colleague Susan Cramdyke about transition engineering, the first textbook on this subject, is definitely worth having on your bookshelf as well. But there's loads more, but read widely is what I'm saying. Okay. And finally, this is where we sum it all up. Instead of the old-fashioned idea that progress is described as more, newer, faster, bigger, we have to start thinking about progress being defined as better, and adopt all those different behaviors so that we can become more effective at delivering that better. And I hope that after that very brief sharing of my thoughts, that you might be able to go ahead, find out more, and be able to make a much bigger difference in your own endeavours towards sustainability. So I thank you very much for listening. Thank you, everybody.
Thank you very much, Daniel. As engineers, we tend to focus on technical matters, but you've really helped us think about different ways in which we can think about applying our engineering and integrating it with considerations of behaviour. And I'll start with the questions now. The first one, I mean, some of these questions were asked quite early on, and I think you answered a few of the points, but I'll take them initially in order. First one from Douglas Nuttall is, does that imply that we haven't really adequately defined the problem, wicked only because we have a too simple problem description? I wasn't clear about what was being referred to, but I think the question really is, are we oversimplifying the problem, and is it wicked because of the oversimplification?
Okay, I think there is certainly. Can I just check? Have I stopped sharing my screen? Can you see me?
Yes, you can see you.
Oh, good. Okay. I think there's definitely a tendency to oversimplify the problems. That doesn't mean that the problems have to be described in a complex way, but certainly there are pressures out there, like the short attention span of the media and the appetite for sound bites, which can end up with the problem being oversimplified. So if the problem is only described in terms of CO2 emissions, then that might be a too simple definition. I've tried to encourage the thinking about the problem as one of continuity, because you can then say, well, climate change plus loss of biodiversity plus social inequality plus water pollution plus air pollution, all of those are just different ways in which we can't continue doing what we're doing. But the problem is actually quite simple. It's about continuity. So yes, there are risks of oversimplifying the problem. As engineers, we should accept to look at the whole problem. It's still simple in terms of continuity, but there are lots of elements. All the different problems all have to be addressed, yes.
Thank you. Next question is from Michelle Chapunza Mindora. Is GDP as a measure of economic success part of the problem? This encourages nations to frame success by the number of goods produced, further fueling consumerism.
Yeah, GDP is a terrible metric. It was never intended to be used the way it's used today, and it only, of course, is a measure of economic activities, not even really a measure of economic success. It just means that there's lots of economic activity. So obviously you can define success however you like, and I do believe that there's an enormous challenge for engineers and other professionals at the moment to create the right metrics. I don't think we have the right metrics. So I know some people have looked at different metrics for like the New Economics Foundation look at metrics for societal prosperity and fulfillment, but they're very difficult to create. But there's definitely scope to create better metrics.
Thank you, Danny. Next question is from Louise Shaw, East West Rail Head of Systems, Rolling Stock. Consumers can only buy what manufacturers are prepared to sell them. Ergo, focusing on consumers will only be partially effective. What's your view on that, Daniel?
I agree completely. That's really why I was saying that we need to look at behaviour change amongst the professional community as well as just customers. So I hope that I've impressed upon you that trying to influence purchasing decisions is a very small lever to pull if you want to make change happen.
Sure, and I think, to be fair, that question did come before you went into that.
Okay.
Jeff. Next question has come a different route. I haven't got a name, unfortunately, but how do you believe engineers can and should influence governments and other public bodies such that they refocus their short-term view of cost-focused projects into more sustainable ones? Denmark has used combined heat and power for decades as they established district heating systems. The UK would never consider this given the cost and the need to coordinate several disparate public and private organisations.
Okay, how should engineers influence government? I think there's obviously lots of ways you can do this, but I always think about how one of our predecessors, Isambard Kingdom Brunel, was noted for spending time inside Westminster to get legislation passed to enable the projects that he was working on. So he didn't wait for a government policy to come out. He didn't wait for politicians to say, oh, let's do this. He went and told the politicians this is what needs to be done. And I've said for a long time that engineers should be telling politicians what needs to be done. And in my experience at IMechE, some might not know this, but IMechE invites parliamentarians into the headquarters building in Westminster once a year for a reception so that engineers can meet parliamentarians. And lots of MPs and peers have told me at those meetings that they want professionals to tell them what policies are needed way before they get to publish a consultation. So I just think that engineers need to frame the relationship with policymakers differently from how we do it at the moment. We need to lead, basically. It's what I said. We need to lead, not follow. So if we can see what the problem is and what the solutions might be, we need to lead.
Thank you, Dan. There's a question from Jeffrey Bell, Saxon King Limited, Director. Should we not also design for refurbishment so that a product can be continuously upgraded rather than one life cycle one? For example, refurbishments of vehicles.
Definitely, absolutely, definitely. And if you look at the circular economy model, the model I showed you just shows one big circle of things going round in a circle, but you know that you can effectively move materials around lots of subsidiary little circles, and refurbishment is an example of extending the life of product so that some parts get refurbished on a big circle and some on a small circle. And design for repair, design for maintenance, and design for refurbishment is exactly one of the strategies that you would apply to make products last longer. Yeah, definitely. So yes.
Thank you. Next question is from Fernando Grando, simulation engineer. As engineers, we usually see ourselves as problem solvers and are seen as well. Now, part of us solving problems today may also be just perpetuating behaviours that actually require change. How should we as engineers be guiding the change, i.e. pointing that not only can we do things today better, but some of the things done today will have to change? Example, are we going to save the world by swapping all cars to EVs, or should we also be pointing out that this is probably not only the biggest environmental issue out there today? I mean, I think you covered that later on to some extent, Daniel, didn't you?
Yes.
After that question was asked.
Yeah, I mean there is a big challenge there, though. I mean, none of this is easy, and the challenge in the question is, how do we do that? And the challenge that you'll encounter is that making and selling 800,000 vehicles a year is obviously financially more attractive than making and selling 10,000 vehicles a year. So there's a big financial inertia to making that change happen. So you need to get around that, and the detail of how you do that is another story. That's in, if you follow the steps of understanding the system dynamics and creating a new vision for an alternative solution, then you can do that. But it's not an easy win at all, but it's what has to be done. Exactly.
Thank you, Daniel. Next question is from Vanessa Richards. I'm struggling with the creation of solutions. A lot of the problems, e.g. heating buildings, distributing food, have to be done. Surely the answer has to be to change the technology rather than not deliver these things.
Okay, yeah, you're right. Even if you completely change the system, you're still going to have to deal with the nuts and bolts engineering challenges, like designing a system that keeps a building at a safe temperature. Of course, that's a given. But what I mean by creating a solution is looking outside of the conventional system. So the conventional system for heating a building is that you, in a town anyway, is that you pipe gas into every dwelling, and you have a machine for burning gas to turn the gas into heat. So you could say, well, we don't want to burn gas, so let's run electricity into every apartment and have an electric heating system to turn electricity into heat. But if you actually look at what you need is a building in which people are safe and comfortable, so it doesn't get too cold in the winter, doesn't get too hot in the summer. And if you start and you try and make the solution, you could say, well, we don't need to have energy conversion technology inside every dwelling. We could do the whole building, and we could put all the difficult and complicated technology into an energy center. And that makes it more easy to have a properly scaled plant and to maintain it more easily, and so on. So that's what I mean by creating a solution rather than just selling the technology.
Thank you. Next question is from Andrew Bradley on transportation. The ideal system solution is to develop systems to avoid transportation, but engineers need to work to reduce the impact of transportation systems as well. How do we keep a balance? Is it about being clear about communicating real whole system impacts?
Well, yes, you certainly need to look at the whole system and do more than communicate the impacts. We need to apply all of our energy, personal energy, and professional efforts to bring about whole system solutions rather than piecemeal, small technological solutions. So transport is a brilliant example, because so much of the system that we operate in at the moment is transport dependent, but it's only transport dependent because it has become that way because we've spent so long being able to afford abundant and cheap fuel to run vehicles. So if you go back to, if you look at towns that were built at the time before everybody had a car, those towns were built so that people could walk to everything. You could walk to the shops, walk to school, walk to work and everything. And we need to be spending the next 2, 3 or 4 decades applying all of our effort to make our towns work like that again, so that we don't have to have cars everywhere. And then maybe we can get by with a tenth of the number of vehicles that exist today. And then the manufacturers will have to adapt their business to make a viable business based on that number of vehicles. And then we'll have a whole system solution that actually works.
Thank you, Daniel. We've got time for a few more questions, but we've just got 3 minutes now. Next question is from Chris McMahon. Daniel, thank you for your entertaining presentation. Isn't one of the key challenges we have that the world, engineers included, is broadly divided into those who believe in continual progress, for example, that we can transition to renewable energy and continue growth, and those who believe that fossil fuels have allowed us to overshoot and that we will have to face increasing resource constraints? The 2 points of view exist that are incompatible, cornucopians versus Malthusians. The techno-optimists probably have the upper hand in public discourse, for example, in the universities.
So what's the question?
So the question is the truth that we have overshot? Well, isn't one of the key challenges that people are split into those 2 camps, those who believe in continual progress and those who think we've overshot with fossil fuels and have to face increasing resource constraints?
I mean, that is a challenge, definitely. But yes, it is a challenge, and it falls into the bracket that whenever you start making change happening, the main challenges are human, not technological. So it's people's beliefs or people's fears. A lot of it comes down to fear. And you might find that a lot of the claimed optimism that business as usual can carry on forever is because people are terrified of the alternatives. So if we can help to create an acceptable and non-frightening vision of a better future, then maybe that will help to resolve that. So it's certainly true that there are different belief systems, if you like, that are not compatible. I don't think that's a problem in itself. The problem is probably to do with fear, and we can certainly help people overcome fear.
Thank you. Well, can you answer one question very quickly and then we'll wrap up? From Catherine Barnard. How do you see us moving to a more thriving economy and metrics? Think Kate Raworth and donut economy, away from GDP and a continually growing economy. Have you got any thoughts on what those new metrics should be? In 10 seconds, if you can, please, Daniel.
No, I don't have a pat answer, and I think that there's an enormous scope for people like you to come up with better ideas for metrics. There's a huge area of potential.
Thank you very much, Daniel, and thank you for everyone for the excellent questions and the good discussion. And with that, I wish you goodbye, and please keep an eye on our future ESG monthly lectures through the website. Thank you. Goodbye.